Mean of a grouped frequency distribution. Consider the grouped frequency table below. The table summarizes the resting pulse rates of 82 adults in beats per minute. So here's our frequency table, and our pulse rate goes from 60 to 70, 70 to 80, 80 to 90, 90 to 100, 100 to 110, and 110 to 120. So this is why it's known as a grouped frequency table instead of just a frequency table, because we have, for example, 60 to 70 is grouped together. So, for example, if one of the adults had a pulse rate of 62, they would go inside this group. If they had a pulse rate of 69, they would go inside this group. If they had a pulse rate of 75, they'd go inside this group, and so on. Note, 60 to 70 means that 60 is included, but 70 is not, and so on. So, for example, if they had a pulse rate of 70, they'd have to go into the 70 to 80 group. If they had a pulse rate of 80, they'd have to go into the 80 to 90 group, and so on. So this is our frequency row. So 5 people had a pulse rate somewhere in between 60 and 70. We don't know exactly what their pulse rates were, but they know that they were somewhere in between 60 and 70. 8 people had pulse rates in between 70 and 80 beats per minute. 22 people had pulse rates in between 80 and 90 beats per minute. 29 people had pulse rates in between 90 and 100 beats per minute. 13 people had pulse rates in between 100 and 110 beats per minute, and 5 people had pulse rates in between 110 and 120 beats per minute. So we can see from the table that 5 people had a pulse rate of 60 to 70 beats per minute. So 5 people had a pulse rate of 60 to 70 beats per minute. However, the table does not tell us the exact pulse rates of each person. In order to estimate the mean resting pulse rate, we must assign each person a resting pulse rate. We choose the mid-interval values as the rate for each group. Another word for mid-interval value is midpoint. So here is how we calculate the mid-interval values, known as MIV for short. So what we do is we take the interval, so for example 60 to 70, we add them together and divide by 2. And we do that for each of the intervals. So we're going to have 70 plus 80 divided by 2, 80 plus 90 divided by 2, 90 plus 100 divided by 2, 100 plus 110 divided by 2, and 110 plus 120 divided by 2. The frequencies stay the exact same. Now we can continue and estimate the mean. So 60 plus 70 divided by 2 is 65. 70 plus 80 divided by 2 is 75. 80 plus 90 divided by 2 is 85. 90 plus 100 divided by 2 is 95. 100 plus 110 divided by 2 is 105. 110 plus 120 divided by 2 is 115. So now we have our mid-interval values. And again, the frequency stays the exact same. So now we have a new frequency table. Remember, the frequencies are the exact same, but it's no longer a grouped frequency table. So we have the mid-interval values along the top row. So we find the mean in the exact same way that we would usually find the mean of any frequency table. We multiply these two numbers together and add them on to these two numbers multiplied together, add them on to these two numbers multiplied together, add them on to these two numbers multiplied together, add them on to these two numbers multiplied together, and add them on to these two numbers multiplied together. Then we add up the frequencies and we divide what we got by the number of frequencies. So it's going to be 65 multiplied by 5 plus 75 multiplied by 8 plus 85 multiplied by 22 plus 95 multiplied by 29 plus 105 multiplied by 13 plus 115 multiplied by 5. And that's all divided by 5 plus 8 plus 22 plus 29 plus 13 plus 5. So 5 plus 8 plus 22 plus 29 plus 13 plus 5. Working out the top row, or our numerator, we end up getting 7,490. And then working out our denominator, we end up getting 82. And 7,490 divided by 82 will round off to 91 beats per minute. So the mean of our grouped frequency table is going to be 91 beats per minute.